This example is going to automate systematically faults applied to the point of connection with the strong grid system. So here's the fault that's going to be adjusted automatically. This is our wind plant, and notice that I have it set at average voltage model, and it's under fixed Q control. And I believe it's set at Q equals 0. We're going to do automation in JavaScript for EMTP, and we're going to make use of this get parameters name function, which there's a new button on this design. So let me double click on get parameters name, and what you can do is put in a name of some object that's on the schematic that you want to automate. So in this case, I put in fault 1. That's the name of the fault that we're trying to automate. And then when I click OK, which let's see, I got to bring it up in the view. There's the OK button at the bottom. We are going to get over here to the left of that button. It's going to give us names of parameters. So one of the things we want to change is, for example, tclose A and topen A with an underscore. And if you scroll down through here, you'll see the similar parameters for phases B and C and a lot of other parameters that can be set for the fault object. We don't need all of them for this case. So I set that up. I've set the time step up. You can look at that at your leisure. But the way we're going to automate this is with this fault script.dwj file, and it is in your zip file package that you downloaded. And I'm just going to go through and highlight some of the components here. So I'm going to run 12 cases, and there's 12 rows in this array called cases. And I have a mnemonic for the case. So the first part of that is the phases involved, A, B, C, and G. And then 80 stands for the 80% voltage sag, the 50% voltage sag, or I should say retained voltage, 25% retained voltage. These values here, these inductances, 0.1057, 0.0264, 0.0088, these are the fault inductances that achieve those retained voltages. The main part of the program is here. I'm using some timing information using a JavaScript date object, and when the whole simulation is done, I can come down here and get the ending date, which includes the time, and I can calculate how many seconds it took to run this test suite of 12 cases. I have some functions here that load script support functions that I need in JavaScript to figure out how to talk to, set the parameters for the ComTrade recorder and also the fault object. And then I have a table-driven execution of the cases. So for each row in that case table, I'm going to set parameters of the fault object, the ComTrade writer object, and then this function is actually going to run EMTP. So it's going to run 12 cases in that loop. The prepare cases function, you can copy and modify these. If you need to find new ones, you look in under the installation directory. There's info scripts, and then a lot of directories under info scripts that you can find what you're looking for. So most of the time we'll need these if you're running EMTP. In this case, I'm trying to automate the fault object and the ComTrade writer object, so I need those. When I want to set the ComTrade writer parameters, all I need to do is change the file names, because the sampling frequency and the channel configuration is all done. That's not going to change. And so what I want to do is change the config file name and the dat file name and then save it. So when I call the save data function, then I'll get the updated information visually on the schematic, and also when I double click on the component again to edit it, it would have this updated information. So the root is going to be, for example, that ABCG80. More complicated function that sets the fault parameters. I'm getting a fault type, for example, and just imagine that has ABCG80 in it. So down here, this set of if-else statements, if I find A, B, C, or G in that name, then I'm going to set the checkbox where the fault involves phase A, phase B, phase C here, or to the ground. And then I also set the resistance and the inductance in each of the phases and ground to those parameters. So each phase inductance is going to be the same in the fault. Each phase resistance is going to be the same in the fault, but there are a lot of other parameters that I could select. So I'm not going to do this now, but if I'm going to scroll down to get the toolbar in the window here, what I want to do is this run script to console. And this is going to take several minutes when I do that. So what you should do is normally run one case here on the basic circuit. Make sure that it runs and it's debugged, and then you're going to go back to the fault script and you'll click this run script to console button, this one right here. When I've done that, we are going to go over to the Jupyter Notebook that'll read that data. So it is cplot4, and you'll type in, you can use the notebook4.bat file to start the Jupyter server and open this notebook in your browser. If Jupyter's already running and you want to load another notebook, actually you can click the File menu here and do Open, and it's got all these other ones that happen to be in the same directory. So I don't need to do that right now. This is already open, but if you don't have to use the same batch file if you're doing a bunch of these at once. So I clicked this first cell to run it to define the support functions. Matplotlib, we've seen this before. We're going to skip a cell because we're going to configure for EMTP import. And here is the list of cases that I ran. And they're using these mnemonics. So in the ComTrade file, so in ComTrade, by the way, you're limited to 8 characters in the file name. That's from the old MS-DOS days. So that's, we're not very verbose in these file names and mnemonics. But this is going to, when I click this, it's going to load all 12 of those ComTrade files, assuming it finds them. And it'll find them if I, had the simulations run and put in that output directory. So it has read 2 of those ComTrade files now. I can put a pause on here. So those files took a while to load because I have so many notebooks and data open in the browser, but I have a little asterisk here, means the cell has completed its execution. And I'm ready to go down to this next cell to plot all those results, and it's going to show up on the same graph. So I'll 12 of those fault cases. So results are pretty much as expected. Remember, this is a 0.3 second fault, so the plant is not required to ride through, and it doesn't all the time. If you look at this this case here, this is the power plot, and it goes to 0. But then when the fault is cleared, it does recover, and it's eventually going to get back up to 1 per unit power output. That's the green trace. That is actually for the sag down to 25% voltage. So the plant ceased to output power. The one where the volted 3-phase fault that took the voltage to 0, the plant went to 0 output and did not come back, but it's not required to by IEEE 2800.